one sign in the front, one arrow in the front, one arrow in the back. Now let's come to the people sitting on the right, so this row of table. For you, of course, this arrow will not point to the left, it will point to the right. And you move to the right, back to the rear and out the emergency exit. And also here, for people sitting in the rear, there's an arrow on the back side pointing also to the right. So an arrow on the back and an arrow on the front. Now let's come to the people in the middle. I would say this middle row. You should, in case of emergency, keep seated. Never stand up. Otherwise, people from the left may collide with people from the right, and people from the right with people from the left. So, once again, never stand up in the middle. Always sit down. And in case you already stood up, then you should call this emergency number. Okay, thank you. Keep this for later, please. So I'll just keep it here so you can remember this number. It's not that difficult. Okay, so now we can actually start. Where is this one? It's here already. How come? Strange. So this is kind of what I'm going to talk about. After a short introduction, I will present some mathematical basics which will help you to do more innovations, and I will also explain how your brain is involved in that. And after that, I will show a real innovation and what we can learn from that. So let's just start. So you are used that you are a physicist. Pardon? This is you. Who? No, this is Habakkuk. Habakkuk. That's okay. This is the colleague. He wrote the book. So if you want to have one example, just tell me. So this is so physicists look always at the reality. However, since the improvement of virtual reality, it's sometimes difficult to distinguish between illusions and reality. So is this still real, or do I just forgot to take off my glasses? So what we can learn from that is that modern experiments in physics or advanced high technology are almost indistinguishable from illusions and seem like magic. And this actually is not new. This was already posted by this guy. This is Arthur C. Clarke. He's a famous science fiction writer. The older people may know him. There's this movie Odyssey 2001, which was kind of very famous. And he put it in a very simple way. He said, this is actually his third law, good science is like magic. And in the following, I will just try to show how you can distinguish between illusions and real science, so that you don't mix it up and you come to real innovations. And in order to do that, let's just start with, of course, real science. And in this case, we start with fundamental science, because this is actually the origin of all innovations. So since generation, ladies and gentlemen, scientists are struggling with the question of time and space. Why, for example, do large objects always require that much space? Well, in very expensive and time-consuming experiments, scientists found out that in small containers, for example, like this briefcase, there is only space for small objects, like, for example, my reading glasses. Whereas large objects, like, for example, this bowling ball, do not fit into such a briefcase. Well, what looks like a flagrant violation of basic laws in physics is actually, and I'm sure you all know that, the well-known topological paradox of first kind. That means there are containers which are inside larger than outside, like, for example, this briefcase. And by the way, this bowling ball is not only very big, but it's also quite heavy. By the way, you know this paradox from daily life as the so-called ladies' handbag phenomenon. Because there's almost no object which does not fit into such a handbag. So with that, I would like to welcome you once again to this evening lecture. And everything what I'm talking about here can be found in this book. This is the Illusion of the Laws of Nature. This is the German issue, but it's also available in English. It's in volume 78, as I said. I think it was on, let me just see, on page 54 till 78. And everything, of course, what's in this book is brand new. It's a so-called hot topic. Anyway. Sorry. Oh, something is happening. Yeah, I don't know why this is working by itself. Anyway, okay. So you may say at this point that, or you may have a question: was this topological paradox real or was it an illusion? Well, the answer, of course, is clear. It is real. It's real science. And in order to show that, I brought a so-called demonstration experiment. This blue box is inside the yellow box because, and this is very important, please pay attention, because the blue box is smaller than the yellow box. This kind of obvious, it seems to be obvious, however, a scientist is able to say this more precisely in saying the outside of the inside blue box is smaller than the inside of the outside yellow box. Therefore, the blue box fits into the yellow box. Now, if this blue box is a topological paradox box, then this blue box is inside larger than outside. Or scientifically speaking, the inside of the inside blue box is larger than the outside of the inside blue box. If not only the inside of the inside blue box is larger than the outside of the inside blue box, but if it's also larger than the outside of the outside yellow box, then it should be possible that the former outside yellow box fits into the former inside blue box. And this is the topological paradox of first kind. Well, such topological paradox